In this section, we'll consider new concepts in modern data-first numerical methods. The world encounters an era of great transition, so you'd better understand these new concepts in computational techniques. Traditional numerical methods exhibit several important properties: consistency, stability, convergence, accuracy, and efficiency. Consistency means the numerical method approximates the correct solution as step size approaches 0. Stability, in a nutshell, is to control error. Once you begin small, then always small later on. Convergence means the solution approaches the true solution as the step size decreases. Accuracy is a measure between the numerical solution and the true solution. Efficiency measures how quickly you can get the solution using computational techniques. Those concepts have been explained using also the picture delivery. Let's consider two more life example. Okay, this is an error. If you have a stable mind, then you can easily recognize and you can understand it. What is it? Real life examples. Okay, sorry about this error. Okay, for stability and in self-improvement, you may consider habit. If you have a good habit, then your life will be more stable. And also in business area, some financial resilience is around stability. The convergence is about continuous learning in life, and business is about customer feedback cycles. Accuracy, and you have to fit well with strength and opportunity. And also in business, you have to get good market need alignment. And for efficiency, you have to prioritize the tasks and focus on those chosen. And there is the rule, which is called the 80-20 rule. Among many tasks you have to do, you prioritize 20% of tasks. If you done this 20%, then you can do 80% of your the tasks. That's the 80-20 rule. So you have to well prioritize your tasks and focus to get efficient the movement, self-improvement, and that is related with resources optimization in business. Life lessons from numerical algorithms are here. You can refine your strategy or your mindset iteratively, and also you can recognize limitations, and you have to adapt to changing conditions, and also thinking step by step. The algorithms are designed in this way, and also you have to give a value, recognize the value of approximation rather than exact solution. You may try to get good approximation for right question or right directional development, then you can give high value for this approximation. So that is in life lessons you can get from numerical algorithms. Here in modern society, here we have paradigm shift. And now we are here working with data first. And traditionally, the approaches are deductive. That means that we start with a hypothesis or theory and test it against the data. But in modern society, the approach is inductive. That means we prioritize and observing the world and then now constructing theories to explain it. So there are steps in modern inductive reasoning, data collection, and we try to understand the hidden structure or hidden meaning through pattern recognition. And now we develop theory and further testing through now data. That is the modern inductive reasoning approaches. For example, now protein structure prediction by AlphaFold developed by Google here, the DeepMind. And the structure prediction was much better than previous method, and also it enhanced the technique significantly. So through AI, and you can make much better in many cases. And also for the proof, rather than rigorosity, now in modern society we are considering feasibility. The traditional numerical analysis start with theory first. But in modern society, many cases we start with data first, and then we organize some theory and testing. And in modern science, the idea of definitive proof is largely replaced by the concept of the strength of evidence. Rather than seeking absolute certainty, scientists focus on how well a theory is supported by empirical evidence. And also, sometimes algorithms are here the more shinier, so the shinier than theory itself. So then these algorithms often overshadow the beauty of a theoretical concept. So you have to recognize this aspect too. And traditional numerical methods rely on known governing equations for solving problems, while modern approaches leverage observed data and partial knowledge of the underlying physics, and in order to construct consistent solvers. One example is physics-informed machine learning, and some physical rules are involved in the machine learning to get a better algorithm. Eventually, such machine learning algorithm is a sort of a hybrid technique. But anyway, right now, the world is changing a lot. The world encounters an era of great transition. Okay, here we'll see the numerical method from a different angle. Traditional numerical methods have been much like lighthouses guiding ships through a stormy sea. These methods are increasingly used in analysis and also interpretation of large data sets, so that this method offers some structured approaches to problem solving that would otherwise be difficult or impossible to manage. That means that the traditional methods are gradually changing toward data first. So here, paradigm new paradigm is made. So observation, inference, and theory, and testing. So data-driven reasoning. So it is inductive reasoning, particularly by using AI. People try to get some inductive reasoning, and now the AI can suggest some possibility. Then using human logic and human intelligence, we can verify so that we can make a new theory. That's new direction. The theory will be developed in this way. So anyway, you have to understand mathematics to develop theory. Even though data first, the reasoning is happening along with AI, eventually human logic should be involved to finalize the theory. So that is a kind of a hybrid verification. So in modern era, numerical methods become task of constructing lighthouse on stormy seas rather than being like lighthouse themselves. So the numerical methods are more realistic and connected with data analysis. Here we have a table, and here the comparing and also the connecting the concepts and traditional concept and modern expansions, stability, convergence and accuracy, consistency and efficiency. And stability is expanded in modern society as adaptability. And also, rather than convergence, the interpretability is now more considered, and robustness rather than consistency. And efficiency is expanded along with the scalability. Once you are dealing with data set, then now huge data requires huge computational cost. The scalability means that the computational cost is increasing linearly as the number of data points increases. Then we say that the algorithm is scalable. So once it is, the cost is increasing much faster than increase of the data points, then it's not scalable. So scalability is an issue. And also for the environment, healthy environment, we have to consider energy efficiency. These are new concepts more frequently later on, more frequently considered rather than these traditional concepts. However, new concepts are based on these traditional concepts. So you have to understand both sides. Now here, finally, we have some life lessons from data first to numerical analysis. Stability is not stagnation, but is adaptability. You have to consider some futuristic and positive mind around the stability. And also error is not failure. If we are dealing with some noisy data set, then in the beginning, you may fail. However, through this failure, you can get feedback to march forward. Numerical algorithms are not merely for numbers, but for insights. The result will give you some insight. Don't miss them. You have to have some new mindset. A new version of a mindset makes a new version of you. So enjoy this music. I try to explain the data first numerical methods along with some comparison with the gardeners. Okay? Okay, and that's it. Thank you.